Now we switch over to another part, which is rice ecosystems. Subrata, are you waken? So to nahi?
Yes, sir.
Everybody is
नहीं सर.
जाग रहे हो सब लोग?
हाँ सर.
Yes, sir. Yes, sir.
सोना नहीं, कभी खाना
Yes,
खा
sir.
के सो जाओ, है?
नहीं sir.
This is also
नहीं, sir. नहीं, sir. नहीं, sir.
okay, good. This is also that was somewhat lengthy presentation, but this is a small presentation of 36 slides. That was having, I think, 65 slides. So it is about rice ecosystem. You know area of rice, and you have variety of conditions under which rice is grown. So just I want to know from you about ecosystem. What is an ecosystem? It is very commonly used now. It is used in business world. It is used everywhere. So, but from the sense of agriculture or crop production, what is an ecosystem?
Sir, this is the surrounding environment of a plant or any organism with respect to both biotic and abiotic components.
Very good, very good, nice.
So surrounding area where living and non-living organisms interact.
Yes, yes, that is also true. Very good. So now we will see different ecosystems of rice, and to understand the various features, constraints, and practices under various rice ecosystems. So you can see an ecosystem is defined as a crop's growing environment or surrounding. Whatever you said was correct. So now International Rice Research Institute 1984 classified rice into 5 groups based on, means they have divided into 5 groups like irrigated lowland, rain-fed lowland, deepwater rice, upland rice, and tidal wetlands. So what were the criteria? What were the basis of this classification? So they considered the seasonal water regime, whether in a particular area, particular ecosystem, water deficit, excess, or optimal levels are there. So depending upon the levels of water, they have divided into different ecosystem. And all these 5 criteria were taken in totality, were taken together. Then drainage, whether drainage is poor or good, means whether water stagnates in a particular area or it disappears. Air temperature, optimal or low. Soil, normal or problematic. And topography. Considering all these 5 criteria together, IRRI has divided rice ecosystem into 5. So I've already told them, we will see in detail these ecosystems. So overall, the major rice production systems are lowland or upland. In the last case, you have seen that in the list you have seen, this is irrigated lowland, rain-fed lowland, and followed by 3 more. So what happens, these 1 and 2, the largest area is occupied by these 2 systems, irrigated lowland and rain-fed lowland. Only 10% area is in upland. So we give more emphasis to lowland area than other area like upland area. So lowland and upland refers to a method of rice production. Please do remember, lowland, upland does not exactly means a kind of land which is lying on the lower side or higher side, or land of higher elevation, higher altitude will be upland, and land of lower altitude will be lowland. It is not like this. It is lowland and upland refers to a method of rice production rather than an elevation where rice is produced. So you can see total area, land area in India, 90% is almost lowland and 10% is upland. Main difference in lowland and upland. Soil is submerged for part or all of crop growth. So whatever duration is there, the major part of that duration of the crop, rice will have or field will have submergence. It will have flooding of water. However, in upland, soil is not intentionally submerged. Soil is not intentionally submerged. See the right wording. It is not by chance for 1 day or 2 days. If it is by rainfall, it is submerged for 1 day or 2 days, then it will not be categorized as lowland. It will still remain upland. In upland, water does not stagnate. The standing water is not there. You will see some more differences in lowland and upland. So actually lowland are further divided into two, lowland, rain-fed lowland and rain-fed irrigated lands. So wherever you get irrigated rice, and irrigated rice, it is bunded and then planting is done and the soil is kept flooded. Then that is also your irrigated lowland. But instead of irrigation, if that land is flooded by rainfall, then it will become rain-fed lowland. That is the difference in rain-fed lowland and irrigated lowland. But in both cases, major part of the field will be occupied by water. Major part of the growing season in the field will be occupied by water. Now you see lowland is further divided into two based on the availability of irrigation water. Irrigated lowland, rain-fed lowland. And you see the rice production, irrigated lowland are the dominating one. Total production area is 55 to 60%. And you see rice production is approximately 75% production. The area is just 55 to 60% of the total area, but the production is 75%. Rain-fed lowland have about 30% area under rice cultivation, and then contribution towards production is 20%. And then rain-fed upland, or you can simply call it as upland. The total production area is about 10% of the total area, but the contribution towards production is less than 5%. So everything is clear about these production systems, that irrigated lowland, you have higher productivity, because of which you get 75% contribution in total rice production. So now you can see the differences in different ecosystem. Here you can see on the top is upland. So it is showing some elevation. It is not exactly elevation. It is just to show you that here the drainage of the water will be faster. You see the water table on the bottom of this picture. These arrows you can see. So in upland, mostly shifting cultivation is followed, maybe in some cases permanent agriculture. Then rain-fed lowlands. Rain-fed lowland, drought-prone, favorable, then irrigated, and then rain-fed lowlands. So rain-fed lowlands are of two kinds. One rain-fed lowland where there may be deficit of water, and rain-fed lowland, you will have excess water here. And then flood-prone rice. So depending upon availability of the water, as you go down, as you move from left to right, the water availability increases. The standing water in the field increases starting from upland, then more water in rain-fed lowland, then in irrigated land, you will have still more water, and then again more water and more water in flood-prone areas. So practices are also different. You can see this interesting picture about these rice systems. So you can see upland rice is about 10%. Upland, you can see, and you can see this picture on the y-axis, you have water depth. Water depth. So you see there is no standing water. There is no standing water in the upland rice. You see these mark of water on the top of the picture, just above the roots. You can see the depth of water here. So then comes your irrigated lowland, then rain-fed lowland, and deep water rice, and so on. So as you increase on the right side, the water availability is increasing. Now see the main differences in lowland and upland rice. So water supply, first thing is that what is happening to the soil. In soil, the fields are leveled, bundled, undrained soils. They are undrained soils. And in case of upland rice, land may be undulating or leveled, naturally drained soils. If rainfall is there, water will not stagnate in the field and it will be lost by percolation or leaching, whatever you call. Then water supply in lowland rice, it can be from rainfall or irrigation as well, or they're combined, rainfall plus irrigation. And then in upland rice, it is always rainfall. There is no irrigation. Water accumulation in the field during major part of the crop growth in lowland rice, water is accumulated. In other case, it never accumulates. Root zone reduced during major part of crop growth. Because of flooding conditions, the reduced zone is formed in the soils of lowland rice. However, in upland rice, all soil is oxidized soil because there is no standing water and your soil is full of oxygen. Then seeding or transplanting. So in lowland rice, it can be either. It can be direct seeding or it can be transplanting. But in upland rice, it is always direct seeding. Remember, under upland rice, it is always direct seeding. Root system in lowland rice is weak. It is thin and shallow. In upland rice, it can be vigorous and deep. Tilling is high in lowland and relatively low in upland. Environmental conditions are stable and uniform. In lowland rice, they can be unstable and variable. Incidence of insect pest disease is low in lowland rice and it is more in upland rice. Input level is high. In upland rice, it is low. Weed problem is not very serious in lowland and it is very serious in upland. Cost of production is high and in upland it is low. Yield are stable to high and yields are unstable in upland. So this is the difference in upland and lowland rice. If you have any question up to this stage, you can ask. Any question I just forgot to, or you can note down your question, we can discuss in the end, or you can discuss now. Yeah, Shruti, you have question?
No, sir.
Yeah, any other person? Okay, we continue to the next.
Sir, I had a question.
Yes, please.
Sir, as you said before that lowland and upland, these are two systems, not that kind of a land.
Yeah.
In reality.
Yeah.
So in the previous slide, this has been said that upland is undulating and lowland rice is in that section it is called level. So
Yeah.
lowland leveled because it is submerged, because it is bundled and made submerged condition is made. That is why it is leveled. And upland rice because it is nothing is done like that in upland rice. In case of upland rice, so it remains undulating. This is what I understood, sir.
Okay.
Is it right?
Actually, in case of lowland, in upland rice, actually, undulating here means slope. The land is slopey.
Oh, okay, sir.
Land is slopey. Here, land is not slopey, it is leveled here. So it is just because under undulating condition, it is not possible to make bunds here, and people do not make bunds. So upland soil means kind of soil where the subsurface drainage is very fast and there is no standing water. And this is the characteristic of upland soils or upland rice soils. I don't know whether I could make it clear or not.
In that case, sir, it indicates that it's a natural condition.
Natural condition.
But you said upland and lowland, these are systems of rice cultivation only.
These are systems. I said these are methods or practices of rice cultivation. Methods or
Yes,
practices
sir.
of rice cultivation.
I said the wrong word. Sorry,
No,
sir.
no problem, no problem. So,
So I was confused actually.
no, don't get confused. In this case, I told you the definition that lowland rice is the rice where water stagnates and fields are bunded. And upland is the rice, upland rice is the rice where fields are not bunded and water does not stagnate. That is the fundamental difference. Rest difference, whatever you are seeing here, they are just artificial differences. They are artificial differences because many times people do not go into the deep into the subject and they ask questions. So many times I have seen that questions are asked for 10 marks from the student that what is the difference in lowland and upland rice. Then student knows only, most of the student know only the one difference, what we discussed now. But rest of the differences we can make so that it becomes a complete answer to the question. So if sometimes any question comes in your career, make the differences in lowland and upland rice, then if you remember all these points, you can explain them well, so that at least you get more points, more differences in lowland and upland rice. So from this table, if you want to write it in detail, in the full text form, in the sentences, then you can at least write 2-3 pages about it. That is the purpose of showing you the extended difference in lowland and upland rice. And it
Thank
was,
you, sir. Now I understood.
yeah, no, is fine. And it was given by Fagaria NK et al. In 2011. So it is normally not, such differences are not given in books. Now,
Thank you, sir.
no problem. We'll discuss these in detail. Irrigated lowland rice ecosystem. So grown on flatlands. Irrigated lowland system means bunded and fields are submerged or flooded. So grown on flatlands where water is accumulated so that rice is grown for the entire or part of the growing season. Remember, entire or part of the growing season in flooded condition. That is your irrigated lowland rice. Examples, these are the state Punjab, Haryana, UP, so on. Grown in bunded paddy fields. Area is approximately 50%, say 22 million hectare. So these are very rough estimate of area. These are not exact because such information is not available. So people give some tentative figures. Irrigation main source of water because it is irrigated, and major cropping system may be rice in South India, rice, and rice wheat. These are the system under irrigated lowland rice, and major problems are yield instability and environmental degradation due to unbalanced nutrient use, inefficient irrigation water management. In Punjab, your water management is poor and yield are of course high, 4 to 5 tons per hectare. And water requirements are considerably high in rice. Each kg of produced rice requires 3,000 to 5 liters of water. One rice crop requires 1,000 to 3,000 millimeter water. Just we have seen that water requirement can be as high as 3,000 millimeter or 3 meters. 3 meters, I think, 3 meters. The total water used to irrigate rice amounts to 24 to 30, means a lot of water is used in irrigated rice. Now, number 2 is rain-fed upland rice ecosystem. For this system, you can simply call upland rice ecosystem. You need not to write rain-fed word always. If you write upland rice, that is enough. Otherwise, to be more specific, you can write rain-fed upland rice ecosystem, but it is the same. Grown in rain-fed, naturally well-drained soils without surface water accumulation. You see, without surface water accumulation or phreatic water supply. Phreatic is your relating to or denoting underground water. There is no underground water contribution to meet out the water requirement. There is no contribution from the groundwater. Without surface water accumulation or phreatic water supply and normally not bunded is called as upland rice. So this is the typical definition of upland rice. A student may like to remember. Grown in rain-fed, naturally well-drained soils without surface water accumulation or phatic water supply, and normally not bundled, is called upland rice. Hugh, 1982, used the term dryland rice, means you are growing rice just like a dryland crop. It does not mean that you are growing it in drylands. He called it as dryland rice and defined it: field-grown rice that is not bundled, is prepared and seeded under dry conditions and depends on rainfall for moisture. Another definition, and mostly in eastern India, this rain-fed upland system is prevalent. Fields are dry, unbundled, and directly seeded. Land can be low-lying also, drought-prone, rolling or steep. 6 million hectare or 13% of the total area under rice, or normally people take it 10% because exact data are not available. It is the choice of the people. Productivity is less than 1 ton per hectare, and mainly because of drought conditions, weeds, light texture soils, less fertile, and nutrient imbalances, productivity is lower. Rain-fed lowland rice ecosystem. So you can see lowland rice ecosystem, poor soil quality, drought, flood conditions, and erratic yields. Area is about 32% of the total area. Both drought and flooding may occur in the same season. That is the problem in rain-fed lowland rice ecosystem. Also classified as favorable, drought-prone, submergence-prone, and drought and submergence-prone. So in rain-fed lowlands, there can be two conditions. One is there may be insufficient rainfall. So under those conditions, drought may be there in rain-fed lowlands also, and there may be excess also. There may be flooding time when you can have excess accumulation of water in the field. So all kind of situation can happen. Drought can happen, flooding can happen continuously, or alternate cycles of drought and floods can also happen in lowland rice ecosystem. Soil fertility is poor and production is highly variable. Like you see, drought and flood, they can affect because it is totally dependent upon rainfall. But most in eastern India, where we get sufficient rainfall or high rainfall. Next is flood-prone ecosystem. Flood-prone here means you get a lot of water, excess water. Yields are low and variable. Flooding occurs during. So when this time will end, will it end at 4? This second.
Yes, sir.
4. So we will continue up to 4. So dear student, we continue with the fourth system, that is flood-prone system. So we have seen one was irrigated lowland system, and other was rain-fed lowland system or ecosystem, whatever you call, rice ecosystem. And third one was upland, or wherever you can number it. And then fourth one is flood-prone system. Here there is excess water. So yields are definitely low and variable under these systems. Flooding occurs during the wet season from June to November, adapted to conditions of temporary submergence. So there may be variety of conditions in flood-prone system, ecosystem. There may be some shallower depth, some medium depth, and some very deep rise. So adapted to conditions of temporary submergence of 1 to 10 days. So in some cases, submergence can be 1 to 10 days or long periods, 1 to 5 months of standing water, ranging in depth from 50 centimeter to 400 centimeter or even more, or daily tidal fluctuations that sometimes may also cause complete submergence. So normally it is partial submergence. Complete submergence means your rice plants are inside the water. Partial submergence means part of the rice plant, the top part is outside the water, but remaining is inside the water. So during the flooding period, the land may be fallow. Flooding period means this flooding will come from rainfall. So it depends upon rainfall. The land may be fallow or be used for alternative purposes such as fish and shrimp farming. Means if there is no water drainage of the water, then you can continue with some other enterprises. In India, 11.4% of total rice grown area is flood prone. Yield is very less, 1.5 tons per hectare. So now this flood prone rice can be of two kinds: deep water rice and floating rice. Deep water, the standing water for certain period of time is more than 50 centimeter. This is official definition of deep water rice. The standing water for a certain period of time means certain period of time during the growth of the crop may be up to more than 50 centimeter. Floating rice, the maximum water depth between 1 to 6 meter for more than half of the growth duration. For floating rice, the maximum water depth between 1 to 6 meter for more than half of the growth duration. Therefore, deep water and floating rice are common in India, Bangladesh, Thailand, Myanmar, Vietnam, Cambodia, Mali, Nigeria, and Indonesia. Deep water rice cover more than 10 million hectares, and millions of farmers depend on them for survival and security. So this is for whole Asia or whole world, 10 million hectares. Now you can see this picture, quite interesting picture of deep water rice, perhaps from Vietnam. And you can see that people are almost submerged in water and full of water, fields are full of water. You can see in some places they are using boat for harvesting of the crop or some other operations in the field. And this is at the time of, say, after heading stage, you can see that water has receded. The water levels have gone down and crop looks like this. So because it was very tall, floating rice particularly, when your water depth increases, the height of the plant increases. So they become very tall. Plant become very tall, and when water recedes, when water come down, then these plant starts bending, they start falling. So kind of stem lodging may occur and field look like this. So excess water is common to deep water rice. The growth and development vary according to the crop establishment practice and the onset, depth, speed, and duration of flooding. As flood water rises, plants elongate, produce nodal roots, and may also produce nodal tillers. Means in the beginning, the water level will be less, and as the plant grows, so will be the water level. So water level rise and growth of the plant, they almost coincide with each other. So as flood water rises, plants elongate and produce nodal tillers. Tillers on the nodes are produced and may also produce roots also. Nodal roots are also produced. So tiller is fantastic. If tillers are produced from the nodes, then they will increase the number of panicles. But what is the role of nodal roots? Roots are released or roots are produced from the nodes in the water, inside the water. So what is use of these roots? Because they are not prop roots. They are not giving support to the rice plant. So what kind of purpose is there for these roots? Yeah, anybody has idea?
For
Sir,
oxygen
if the
supply
rice
in
plant
arid
is big,
condition.
Pardon?
sir, if the rice,
What will be
hello,
the
sir.
role?
Hello, sir.
Yeah.
Sir, if the rice plant is break from the node and if we node are established in a puddle field, then it will produce another plant. It's also happened.
See, I'm talking about floating rice or deep water rice, where plant height is very large, very big height, plant height is there. And some nodes and internodes are there in the water. I'm not talking about soil. They are suspended in water. And in water, these nodes are producing some roots. So what is one is tiller. Tiller is produced by nodes. Other is roots are produced by the nodes. Then what is the function of these aerial roots? They are not in air, they are actually in water. What is the function?
Sir, oxygen supply.
Yeah, you have come to the point. So whatever oxygen is dissolved in water, very insignificant quantity of oxygen is there in water that is taken up by these roots. This is number one objective, and other they can absorb certain mineral elements also. So some nutrients may be dissolved in water and they can help in the uptake of those minerals. And water levels may reach 100 centimeter near the end of the monsoon season. When photoperiod sensitive rice varieties flower, as the water recedes, grain ripens. Crop duration may be 300 days and harvest may be on dry or wet fields. So it depends. And sometimes the deep water rice harvesting time, there is enough water, sufficient water, or water levels are high. But it is also possible that water has completely receded, completely removed. So major features of floating rice, it is a semi-prostrate, means the plant is not very straight. It is bended plants are there. Appearance near the base of the plant, even in early growth stages under shallow water. Ability to elongate rapidly under rising water conditions. Up to 10 centimeter per day, it can have growth, it can increase in height, 10 centimeter per day. If water rainfall is 10 centimeter per day, okay, it will increase the same height. Formation of adventitious roots at the higher nodes or younger nodes. A distinct photoperiodic type of flowering behavior. Leaves appear to float on the surface. When water recedes and flowering occurs, a tangled means intermixing, tangled mass of stem result. The upper portion of the stem usually exhibits phototropism, which reduces the damage to the panicle caused by water and mud. So I'll show you some pictures like this. You can see in this picture. So initially you can see the x-axis. On y-axis, you have water depth. So pre-flood 2 to 3 months means there was no rainfall. So at this time, people can go for seeding. Direct seeding can be done here, or people can do transplanting because there may be some rainfall during this time, but rainfall may be less. But here, the transplanting can be done or direct seeding can be done. And then for the next 4 to 5 months, there will be flooding in the field. It will be full of water. And then comes the post-flood period when the water levels will go down. So post-flood period may be usually 1 to 2 weeks. So you can see it's from starting to end. Now you see the height, the blue lines in the picture. So initially the height of the water in the field is less and then it increases. You can see it increases in the middle of the growing season and then it comes down, blue line, just see the blue line, this waving of the line, and then it comes down further. So this is how the water levels and crop growth happens in this kind of rice, floating rice. And you can see one more picture, the almost same kind of picture. and where starting from A to F, different stages, and you can see the leaves are floating and plants are bending. Plants are little bit bending here. And you can also notice some roots on the nodes inside the water. You can see those nodes here. So now you see A, B, C, D, E, F in this picture, even G and H. These are the stages, and they are explained in next page. They are explained here. I will not read for you. So you can see when a particular stage is arriving, what is happening at A, B, C, D, E, F. So you yourself can study it if you have interest. You can see the nodes, nodal roots, nodes and nodal roots, and upper node on the water surface supporting a shoot, a knee. So some structure like knee is formed. So it supports the internode which is above this. So nature may have made it some like, supporting structure. This roots and this thickness, bending, this all is engineering of the nature so that plant can come out from the water to give the support to the plant. So nodes and nodal roots. Number A, point A here, A picture is there. So meaning of A picture here is an upper node on the water surface supporting a shoot. Number B picture, you can see nodal roots developing just below the water surface. Nodal roots is started developing, and C is well-developed nodal roots at the knee. In floating rice, it is called as knee, K-N-E-E, knee. Nodes and nodal roots, you see D. So they can be fully developed here. You find fully developed nodal roots below the water surface. A nodal tiller has developed from the node. So you can also see one tiller has developed from here. So this is very interesting in floating rice. And this figure you can see panicle, advanced panicle emergence. Panicle emergence is there. It is getting away from, getting separated from the flag leaf, and then mature panicle. You can see mature panicle in the picture. And this is ripening field. So lodging kind of things will happen, and kind of jungle raj, there will be intermingling of the stems and panicles. So harvesting becomes very tough at this stage. You can see they will lie on the ground like this. So these are ripening phase, ripening fields, mature stage, showing the cows of prostrate and semi-prostrate panicles on the collapsed plant canopy. So kind of mixing is there. So growing practices of deep water rice. Traditional deep water or floating photoperiod sensitive varieties are grown. So first condition is that they have photoperiod sensitive varieties, dry seeded at the end of dry season. So dry seeding can be done, or transplanted at the onset of the monsoon, and harvest is done when monsoon rains are over. Yields are very low, 1 to 1.5 tons per hectare, and where flood water rises rapidly, crop failures are common. In these regions, crop failures are common. In places where water recedes gradually in October or November, farmers prefer to grow a transplanted crop of improved early maturing photoperiod insensitive variety. Yielding variety means after this crop, on residual moisture, one can grow a succeeding crop of rice. So you can see this table summarizes methods of crop establishment commonly used in rain-fed rice ecosystems. So you can see method: direct seeding, dry seeding, wet seeding. So upland condition, it is always dry seeding. Then rain-fed lowland, if they are shallow, favorable, then dry seeding and wet seeding can be done. And then shallow submergence prone, shallow drought prone, and so on. In many of these conditions, both the options are available. One can go for dry seeding or transplanting. In general, low land preparation of weeding is required and the crop matures on residual soil moisture. So this is for the succeeding crop, next crop of rice. Variety should withstand water depths greater than that normal for irrigated rice. Although practice appears attractive, it is not always possible to adopt it in the vast areas where water recedes too rapidly to allow a short duration variety to mature. Only in cases where water stays in soil for longer time, then you can grow a short duration variety, rice variety in succession after the deep water rice. Otherwise, in many cases, it is not possible. So this is just summary characteristics of rice ecosystems and their constraints. So you can see ecosystem: irrigated, wet season, Kharif season 4 to 8 tons per hectare. Bunding, puddling, transplanting is done in this. And constraints to production are occasional drought if tube well water not available. Drought micronutrient deficiencies are coming up in irrigated rice. There may be moderate weed problem or disease and pest problems. Irrigated dry season in Rabi. So irrigated rice in lowland can be in 2 season or 3 season, and it can be wet season or dry season. In dry season, yields are generally less, 3 to 5 tons per hectare, and bunding, puddling, transplanting is done, and occasional drought if irrigation water not available, and micronutrient deficiencies and weeds. But weeds are less in dry season than in wet season. Rain-fed lowland, a maximum water depth tilling to flowering can be 30 centimeter to 1 meter, and yields are more than 2 tons, and bunding, puddling, transplanting can be done, and flood, drought, heavy incidence of disease, pests, weeds. So these are some characteristics, features. And see, rain-fed upland or upland simply, maximum water depth during tilling to flowering can be 0 to 30 centimeter. This is somewhat out of place here. There cannot be standing water in rain-fed upland, and fields are unbundled and direct seeded. Of course, drought and flood happens, heavy weed infestation, then deep water rice broadcast in unbundled dry fields before. So you can, you are already explained about this. So here is thank you. Now one exercise is left. One exercise is left. So I will finish that in quickest possible time. Just wait for a minute. I will continue another presentation.